Hi everyone, I am Chahat, a PhD student at NCRA. So today I'll be talking about a multi-frequency study of a repeating fast radio burst, that is FRB20201124A using uGMRT data. So before moving to the source, I would like to briefly talk about what hyperactive repeating FRBs are. As all of us know, FRBs are very short, extremely bright radio pulses originating from cosmological distances. And majority of FRBs are one-offs, but a small fraction, around 3 to 4% repeat, and they tend to show broader pulse widths and narrower bandwidths. Among these repeating FRBs, their repetition rates vary widely. Some of them show a few bursts over years, and the hyperactive repeaters show hundreds of FRBs, hundreds of bursts per hour, and these are those hyperactive repeaters. This hyperactivity often appears as burst storms, which lasts for a few days to months, and this hyperactivity is possibly triggered by magnetar flares or star quakes. And another fascinating property of hyperactive repeating FRBs are their diversity in polarimetry. Some of them show high linear or circular polarization with the variation in polarization angle and reversal of RM sign. And some of the FRBs show complex substructures, even show downward drifting in frequencies, and all of these properties suggest that the source might reside in a strong dynamic magnetic environments. Now, in today's talk, I'll talk about this hyperactive repeater, that is FRB20201124A. So this FRB was first discovered by Chime in November 2020, and the activity started in March 2021. During follow-up, FAST detected more than 1800 bursts in 82 hours over 54 days. So these are the number of bursts, and this is the burst rate as a function of observing time. This is MJD, and this gray shaded region is showing the non-detection period. And this FRB also showed RM variation on a day time scale. And this FRB showed almost around 100% linear polarization friction and more than 50% circular polarization friction. This is the first repeating FRB which showed circular polarization. Before the discovery of this FRB, the circular polarization was one of the property to distinguish between one-offs and repeating FRBs. By seeing all these unusual properties like RM variation on a day-time scale and circular polarization in repeating FRBs, Wang et al. Proposed a model of a binary system in B star and magnetar. Now I'll not go in the details of this model, but if you're interested, we can discuss this model later, or you can refer to this paper by Wang et al. Next, this FRB drew attention when 1.7 second periodicity was reported using the same FRB data during two epochs, that is these MJDs 59310 and 59347. But later on, another group reanalyzed the same data, used same techniques, and they couldn't detect any periodicity. After that, this Zhang et al. Compared these MJDs, these two MJDs 59310 and 59347 with this, compared this MJDs, and later they found that these MJDs are lined here as shown by the crimson and blue lines. So these lines are showing here that showing the system when it is switching between unstable and stable states. And even though 1.7 second periodicity is debated, but still these epochs are showing some kind of orbital or magnetospheric modulation in the system. Now moving to the uGMRT observation. So we have observed, if you observe this source between 8th May to 15th June in 2021. And this was the observing setup from 8th May to 28th May. We simultaneously observed this source in band 4 and 5 and with this time resolution. From June 12th to June 15th, we simultaneously observed the source in band 3, 4 and 5 and with the high time resolution. And the motivation to observe this source was first to cover the wide frequency coverage, wide frequency range in ranging from band 3, 4 to 5, 300 to 500, 550 to 950 and 1060 to 1460 megahertz. To test spectrotempo variations, to test progenitor models and to search periodicity. And then we have detected a total of 146 bursts during uGMRT campaign. This is MJD, this is calendar dates, and this y-axis is representing number of bursts. So we have detected 141 bursts in band 4. These blue bars are showing the detection of band 4, and this orange bars are showing band 5 bursts. We detected only 5 bursts in band 5, and this gray region is showing no detection period. This right y-axis is showing observing time, and the purple line is showing the observation time. And this is the gallery of band 4 bursts. So it is showing a diverse morphology of bursts, say from narrow band to narrow burst to wide burst. Some are showing multi-components, some are showing downward drifting in frequencies, and independent plus subcomponents, the nearby events, and so on. Next, from our data, we saw there are some sub-second bursts also present. As you can see here, these all are independent bursts, not subcomponents, and the separation between these consecutive bursts are varying from tens to hundreds of milliseconds. And we searched for periodicity in our data, but we couldn't detect any periodicity. And from the earlier studies, like they found, the authors found some 1.7 seconds periodicity, although it was debated, but we have also seen in our data sources emitting bursts in the millisecond duration separation. So from this data and 1.7 second data set, we might say that the source operates across multiple temporal regimes, and the range lies between milliseconds to seconds. Next, we have generated a waiting time distribution. Waiting time is the interval between consecutive bursts. And in our data, we saw a bimodality in waiting time, and this we have fitted this data with 2 log normal function, and the short time scale is peaking at 48 milliseconds. The long one is peaking around 120 seconds. And we compared our data with the literature with the same FRB 20201124A and another FRB and this 1809116B. So from this, we saw that all of these are showing bimodality, and the short peak is coming at near 50 milliseconds. So from this, as we are getting bimodality and 50 millisecond time scale, so this 50 millisecond may suggest a common intrinsic emission mechanism. And in one of the papers, Zhang et al. Reported that this 50 millisecond time scale may signify some fundamental properties of the FRB source. Next, I plotted a cumulative burst rate as a function of fluence. So I fitted this data using a broken Pavlov and got these 2 indices for this region and this region. And break is occurring at 16.89 Jansky milliseconds. And then I generated an energy distribution. Energy distribution is also showing a bimodality. And the same, this break, the 16.89 Jansky millisecond, when I plotted here, it is appearing here, and it is showing some kind of physical transition between 2 states. And this energy distribution, this bimodality is also being seen in the same FRB by Zhang et al. And from this biomodality in energy distribution, we may indicate that there might exist more than one emission. And after that, as we observed our source simultaneously in band 4 and band 5. So from band 4 and band 5 data, we saw there were two epochs, that is 9th May and 18th May. On those epochs, the bursts were in closer temporal proximity. The band 4 and band 5 bursts on 9th May showed a temporal offset around 1.15 seconds, and on 18th May they showed a temporal offset around 1.08 seconds. And during the same time, Fast was also doing the follow-up. So from the literature we saw on 9th May and 18th May are the epochs where our GMRT data is overlapping. But when we did a rigorous study, so we found that on 9th May, when our GMRT observations began, around that time, Fast observations just ended. So we couldn't detect any simultaneous burst on 9th May. And we compared our GMRT band 4 data with the Fast L-band data. So the closest event was separated by 5 seconds. And on 18th May, we found, we detected 2 bursts in GMRT band 5. And these 2 bursts appeared in L-band. We checked this. And when we compared band 4 data of 18th May with Fast L-band data, so we found that the minimum separation between bursts was around 66 seconds. So the takeaway of this multivariate temporal study is that first we found from GMRT band 4, band 5 data, the separation is around 1 second, and this is either intrinsic or due to propagation effects rather than instrumental. And from GMRT Fast data, we saw that there are multiple bursts which were closely separated by minimum separation was 5 seconds and then 10 seconds and longer across GMRT band 4 and Fast L-band data. And we couldn't detect any simultaneous bursts in band 4 and GMRT L-band data, but the bursts occur in nearby frequency windows, and it also indicates a frequency dependent emission. After that, in this plot, I use all the observed GMRT bands. This blue band are showing band 4 data, and orange bars are showing band 5 data, like I shown earlier. And this pink ones are taken from Maan et al. And Bilius et al. So from this plot, we can see that although we could detect only a few bursts in these epochs, like before 28th May, but yeah, there was a detection in band 5, but after 24th May, we couldn't detect any burst in band 5, although we didn't have data here on 25th May, but still we had a detection in band 5. But on 26th May, Fast reported that they are seeing a cessation of activity in L band. So after 26th May, they couldn't detect any burst in L band. But on 28th May, we could detect burst in band 4, which shows a frequency dependent emission. And later on, this band 3, band 4 detection was also captured by Bilius et al. And it confirmed that it is showing a frequency dependent activity cycle. And to summarize, we have detected 146 bursts, most of them in band 4 and few of them in band 5. Also, we have seen a chromatic activity in which a high frequency emission seized earlier, and we also saw subsequent repetition, and the range varies from tens to hundreds of milliseconds. We saw a biomodality in waiting time and energy distribution. Also, we saw a frequency dependent emission. So I stop here. Thanks. I'll be happy to take questions.
Questions for Chahat? Yes, Vishal, please.
Great talk, Chahat. So I have a question regarding the bimodality conclusion that you drew. If I recall, when 12.11.02, we found something similar and fast, there was a question that the bimodality that we saw was actually due to the out-of-band emission that we could capture with the fast band.
Are you talking about energy or waiting time?
I'm talking about the bimodality energy.
Energy.
Yeah.
Okay. So
How confident are you? Because currently, I guess you have a overlap, not overlapping, but like adjacent band 4 and 5 that you probably place right next to each other.
No, so here I have taken only band 4 bursts, because in band 5 we had only 5 bursts.
So my question is that when we reported this bimodality on 12.11.02, papers came out later on which suggested that it is not real bimodality, but it is because of the out-of-band emission that we failed to capture.
Mhm.
How confident are you that that is not happening here?
Not wrong. So in first repeater FRB201102, for the energy calculation they have used they haven't used usable bandwidth, the emission bandwidth, but they have taken the complete bandwidth. And then the next paper said there is no confirmation of bimodality and this is of no use, or kind of it's not correct, the interpretation. But in this case, although we have taken all kind of bins, so by binning we have seen the bimodality. And for the energy calculation, again, I haven't used usable bandwidth. I have just taken the complete bandwidth, the 200 megahertz. The problem is because my burst had a lot of RFI, so I couldn't estimate the correct usable bandwidth. So I took usable bandwidth, not that emission bandwidth. So
More questions for Chahat? Yes, please.
Great talk, Chahat. I have rather naive question. So how do you differentiate independent bursts from subcomponents that you mentioned?
over here, if you can see, I will call it as a independent burst rather than subburst, because when if it touches a mean level, if it comes near 0, then we call it as independent burst. If it doesn't touch the mean level, like here, if you can see, this is not touching the mean level, the 0 level, we'll call it as subburst. But here it is touching this mean level, 0 mean level. Then this is an independent burst and this is a subburst.
So like you study the temporal signatures and differentiate based on that, right?
Yes.
Yeah. Okay, thank you.
By fitting this.
So I have one. Oh, sorry. Yeah, please. Which can you pass on?
There was no pattern. I generated a distribution of fluxes, but I couldn't see any pattern. Here I haven't shown, but yes. Flux density. Which plot are you talking about? Okay. I generated a distribution, but I couldn't see a pattern.
Sorry, this is just a follow-up question on the previous one. So don't you think that if you consider the small element as a separate burst, are you, so for example, if GMRT was more sensitive, probably we might have seen a trailing component that connects the major burst and the second burst both.
For this first?
Yeah. So, I mean, is it fair to consider that as two different bursts? Or are we limited by the telescope sensitivity?
saw these are two different bursts, but you're talking about sensitivity. So you're saying rather considering this as an independent burst?
It not considering that as an independent burst, considering everything as a single burst, because it may be a component of the burst, and just the telescope noise is so much that it's not showing up. That's it. Like, for example, if the noise floor was much below than this, maybe there is a possibility that these both would connect, and it's just a microstructure that the whole single burst has been shown like this.
The time resolution of this burst is actually not so good. It's 327 microseconds. So
Okay.
if we have higher time resolution, then I can comment on this.
Okay,
whether
okay.
These
Yeah.
are sub burst or independent burst or.
Sure, fair. Okay, thanks.
Okay, so I had a quick question that you had two kinds of bimodality. Is there any interrelation between these bimodalities? Like these, the bursts which are in the, say, lower energy, whether they are getting more delayed?
Okay, so I generated a plot between waiting time and energy difference. So, but I couldn't find any correlation between them. So I cannot say low energy burst and time relation.
Okay, good. Thanks for the interesting talk. We don't have any question from online participants. So let us thank Chahat. So our next talk is